So today will be our third lecture on bottom-up parsing, and in today's lecture we'll go through this example. So this is going to be our second example. We'll do it completely. So we'll do a complete example, and this is going to take most of the, if not all of the lecture today. So last time we did one example. Today we'll do another example because I think one example is not enough to understand LR1 parsing. So okay, so let's do this. So now this is our grammar, and again it looks simple, but we will see that constructing an LR1 parser for this is going to take a lot of computation and bookkeeping. So it's but it's a little bit more complex than the one that we did last time. So now, so what's the first step? So the first step is computing the states, the different states, or the canonical collection. Collection of states. Collection. Canonical collection of states. So these are the different states. And what does each state have in it? Each state has in it a number of what we call LR1 elements. And what's an LR1 element? What's an LR1 element?
Has a rule and look ahead.
Look ahead and one more thing. So rule, look ahead, and what's the important little thing that we use to track the progress?
Oh, the placeholder.
The placeholder, yeah. So the rule is going to look like alpha, placeholder, beta. Then you have a look ahead of little x. Okay. So what does it mean when we have an LR1 element like this? So this is a production, but with a placeholder and a look ahead. So what does this mean? What does this LR1 element mean? So it's a state. It represents the state. So it means that what we have parsed so far is consistent with alpha. So we have parsed an alpha. Whatever that alpha. So this alpha may be 1,000 symbols, 1,000 terminals and non-terminals. We have parsed an alpha, and we expect a beta, or it's one of the possibilities. Remember that each state will have in it possibly multiple LR1 elements. So each LR1 element is a possibility. So one of the possibilities, we are expecting a beta. And if we get a beta, this will lead to this in the next state. Mm-hmm. Then, if we get to this, we can reduce alpha beta to x. But under the condition that
your look ahead is x.
The look ahead is little x. Okay? So if we get to this point, this means that we can reduce alpha beta to x if the look ahead is little x. If it's not, then we cannot reduce. Okay? All right, so these are the LR1 elements. So they track the state of the different productions. So basically, LR1 parsing is about tracking the states of the different productions, and then in a given state, by looking at the state and the look ahead, we decide whether we are ready to make a reduction or we should do a shift. Now, if both a shift and a reduction are possible, what does that mean?
Invalid. It's invalid.
What do you mean by invalid? You have to be careful about using the word invalid.
It's not proper LR1.
Yeah, so the grammar is not LR1. The grammar in its current structure, in its current format, is not an LR1. We may be able to modify the grammar and make it LR1, and we may not. because the language may not be an LR1 language at all. So if there are multiple possibilities, then this particular parsing technique fails. We cannot use this particular parsing technique unless we try to modify the grammar. But if there are no valid possibilities, what does that mean? If at a given point there are no valid possibilities,
Syntax error.
syntax error. It means that there's nothing wrong with our grammar or our parsing technique. The input string has a syntax error, so the input string does not belong to the language that this grammar generates. Okay, so now first thing is state S0. So the first thing that we do is state S0, the initial state. And state S0 here is going to be always standard goal X. And what should the look ahead be? End of file. And where should we put the placeholder? Before the X. So this is easy. This is the first step. Now, is this all what we need to do in state 0? No. What should we do?
Look at all the productions that can derive X.
Yeah. So this process of looking at all the productions that can produce X, and then looking recursively into whatever non-terminals appear in those productions, and keeping doing this recursively until we get to terminals. What does this process, what is it called? What did we call it last time?
Yeah,
So this is computing the closure for this state. The closure going recursively and first doing all the productions for X. And in this case, we have two productions for X, X, AB, and X and AB terminals. Okay, so these are the two productions. Now, what should the look ahead be?
end of file.
End of file. Why? Because this is something that will substitute for X, and X is followed by an end of file. But if we had something here, then we should look at the first of this thing. So if we had a delta or something here, we should look at the first of this delta. And if the first of this delta has epsilon, then we should still include end of file in the possible look aheads. So there may be multiple possible look aheads. It's not a single look ahead that is possible. Okay? So now the placeholder is here, and the look ahead is end of file. Now, are we done with the closure?
No.
No. Now, we have a placeholder preceding a non-terminal. Whenever you have a placeholder preceding a non-terminal, you have to keep going. Now, what defines an X? Now, this is the next level of X. So let's, in fact, let me put these. Okay, let's keep it like this. So this is X, but this is, we can think of this as level 0. This is level 1, and we may have many other levels. So in this case, we have level 2, where X is, again, we put all the productions for X. Now, what's the look ahead? The look ahead is AY, because this production came from this production. So this production was implied by this. So this is a possible substitution for X, and the possible substitution for X will be followed by an A, unlike the X that appears at this level. So the X that appears at this level is followed by an end of file. But the X that appears at this level is followed by an A. So because this is a substitution for the X, so the X at level 2 is a substitution for X that appears at level 1, and that one has a follow of A. So we put the A, and then this is level 2. So where should we put the placeholder?
The start.
Yeah, at the start, because this is we are still at the start of the x. So x is at the beginning. So this is again at the start. Okay, any questions? Okay, so now we have all the definitions of x. Now, are we done? Well, we should in fact look at, again, there is a non-terminal preceded by a placeholder. So we should put all the productions for x, and they are followed by an a again. So it will reproduce this again. So it will not. So we should, in general, whenever we have a placeholder before a non-terminal, we should look at all the productions that define this non-terminal. But if we do so here, it will just give us this again. So level 3, in fact, there is an infinite number of levels. Level 3 is going to give us exactly the same thing. X, A, B, A. Don't write this because I'm going to erase it. But just to show you that we can potentially have level 3, but it's the same. So did not add any new productions. So we just don't do it. And level 4 is going to be the same. So level 4 and 5 and forever are going to be the same. So they're not adding any new productions. So we stop there. We stop at level 2. Okay, so now this is our state 0. This is our start state or initial state. What does this initial state mean? It means that this is all the possibilities in the beginning. We are at the beginning of this at level 0. We are at the beginning of one of these at level 1. And we are at the beginning of one of these at level 2. Okay. Now, what's the next step? Transitions. Now, we have transitions here on 2 symbols. What are the 2 symbols on which we have transitions?
X and A.
X and A. Why don't we have a transition on a B?
There's no dot in front of a B.
Exactly. So there is no placeholder before a B. So we only have transitions for X and A. No transitions for B because there is no B preceded by a placeholder. Okay, so if we get an A, if we get an X, these will make progress. So let's look into the X. So this is going to be, next state is going to be go to of S0 and X. Go to of S0 and X is going to give us S1. State S1 we are about to write. So S1 is going to look like this. Goal. What should we write? So if we get an X, the placeholder will move. So these placeholders are tracking the progress. So we're going to get this end of file. Anything else? Yes. So we look at all the X's that are preceded by placeholders. So this one is going to give us X. X dot AB, end of file. And what else? This is going to be X placeholder X placeholder AB A. Okay. And of course here we ignore this and this, the ones where the progress is on an A. So because here we're tracking the progress on S, the transition that will happen when we recognize an S, when we recognize, an X. Okay, so this is state number 1. Well, we should consider the closure. So do we have a closure here? If we compute the closure, we look at what?
Any non-terminals that are after?
Yeah, exactly. We look for non-terminals that appear after a placeholder. Do we have a non-terminal appearing after a placeholder? No, so we stop. So the closure here is not going to add anything to this. Okay, so now this is our state. Now, do we have any reductions in this state?
Goal.
Yeah, goal, because this reached the end. So whenever the placeholder reaches the end, we have a possible reductions. So this is a reduction by rule number 0. Reduce by rule number 0. Now let's look at, go to of S0 and A, the transition on an A that leads to S2. We have already used 1. So S2, and this is going to be what? X. So we look at these ones. This and this, okay? The ones on which there is a transition on A. So we look at X goes to what? A, placeholder B, end of file. X goes to A, placeholder B, A. Okay. Now we should ask, what's the question that we should be asking now?
Closure.
Closure. Do we have will the closure add anything? No, it will not, because we don't have a non-terminal appearing after a placeholder. So only terminals here appear after placeholders, so the closure will not add anything. Now, do we have any reductions in this state?
No.
No. The placeholder is in the middle, so no reductions. So this is, this is state 0. This is state 1. And this is state 2. Now, state 3. Okay. Now, no other transitions. Now, we are done with S0. We covered all the transitions out of S0. So we look at the possible transitions out of X1. Now, go to S1 and... So S1, in S1, we have transitions on which variables?
A.
Only A. We don't have a transition on B, because we don't have a placeholder preceding a B. And we don't have a transition on X either, because the placeholder appears after X. So the only transition out of S1 is going to be on an A. Okay, so go to S1 and A. This is going to give us... Okay, so now we will look at only these two productions. X is going to become X. X is going to become X A, placeholder B. So we're making progress. End of file. And this X is going to be X A, placeholder B with an A. I look ahead of A. So this is, and again, do we have a closure? No, because this is a terminal. That's why we will be able to complete this example in this lecture, because there aren't very many terminals preceded by placeholders. Yeah, question?
We are in state 3, right? S3.
Yeah, so this is S3. Is S3. So this is S1, S2, and this is S3. So first question is, do we have closure? Will the closure add anything? The answer is no. The closure here will not add anything, because the placeholder precedes only terminals. Second question is, do we have reductions? No, we don't have any reductions. Why? Yeah, because the placeholder is in the middle. We don't have a placeholder that reached the end of a production. So we are not ready to make any reduction at this point. Now, these are the only transitions out of S1, because we're only transitioning on A. So now we look at transitions out of S2. So go to S2 and what are the transitions out of S2 on which variable? B. S2 and B is going to be S4. And S4 is going to be you just advance the placeholder. X goes to AB placeholder, end of file, and the other X goes into AB placeholder A. Okay. So now first question is closure. Closure will not add anything because we are already at the end. Second question, reduction. Do we have reductions? Yes, we do. We have two reductions. So we have this reduction. This is a, or let's do it in red. Yeah, let's do the reduction, mark the reductions in red. Okay, so this is going to be reduction by rule, rule number 2. And this is a reduction by rule number 2, same rule. And this is our state. So this is going to be state 4. Okay. Now, do we have any more states?
From S2.
So from S2, there is only one transition on B, and we have already covered it.
S3.
Now, S3, we still have transitions because the placeholder is not at the end yet. Okay? So now, we have another transition. So go to of S3 and A or B? B. S3 and B is going to be S5. And S5 is just we advance the placeholder X, X, AB, placeholder is here, end of file, X, X, AB, placeholder A. And this is state S5. Now, first question is closure. Closure will not add anything. Second question is reduction. We do have reductions, right? So we have reductions. Okay, reductions using rule number 1. This is rule number 1. X reduces to XAB, so this is rule number 1. Okay, so now these are the states. You know, in fact, we can draw these states like this. So this is our S0, and S0 can go to S1 or S2, right? So with an X, it goes to S1. With an A, it goes to S2. And S1, with an A, it goes to S3. And S2 on a B, it goes to S4. And what else? S3 on a B goes to S5. So these are this is the transition diagram. Or in fact, yeah, you can think of this as a DFA, but this may be confusing for some people. So, you know, some people may think that it's a regular language. It's not a regular language, but you can think of this as a DFA. Well, you think of this as a transition diagram. Okay. So now let's construct what? What should we construct next?
The go-to table.
Yeah, the go-to table. And the go-to table here is very easy. The go-to table, remember, only includes non-terminals. So here, with S0, we go to the only non-terminal that causes a transition. It's easy. X causes a transition from S0 to S1. From any other state, S3, S4, S5, okay? Any other state, it's going to be nothing. Yeah. In fact, let me just do it smaller so that we can use the space. So I'll just do the same thing, but S1, S2, S3, S4, S5, and we transition to nothing. Now the action table. The action table is, so we have the states. S0, S1, S2, S3, S4, S5. Okay, what should the columns represent in the action table?
All the terminals.
The terminals, including end of file. A terminal or end of file. Because when we are parsing, our look ahead is either a terminal or an end of file. So remember, in the action table, we only have end of file or terminals. In fact, it's I'll just move this a little bit. We have okay. So I'm not going to change it. So S0, S1, S2, S3, S4, S5, and this is end of file. What are the terminals that we have here? A and B. So now constructing the action table is interesting. So we can have a reduce or a shift. Now the question is, we are in S0 and we are seeing end of file. What should happen? Well, first we check for a reduction in S0. S0, does it have a reduction? No, it doesn't have a reduction because it doesn't have a placeholder at the end. So there is no reduction. And is there a transition? No, there is no transition on end of file, so there is nothing. So we leave it blank, or we just put a nothing. So if we are in S0 and we get end of file, then this is invalid. We are in S0 and we are getting an A. So first of all, we note that there are no reductions here. In S0, there are no reductions. There is no placeholder at the end. So we can only have shifts. So with an A, we shift and we go to S2. With a B,
Nothing.
that's invalid, nothing. So if we're in S0 and we get a B, then the input string has a syntax error, does not belong to the language. If we're in S1 and we look at S1, are there any reductions?
Yep.
Yes, there is a reduction if the look ahead is
End of file.
end of file. So if our look ahead is end of file, then we have a reduction. And this is a special kind of reduction. It's an accept, yes. Okay? Now if we had multiple reductions, this would have been a reduce error. And then this would have been a failure of the LR1 technique. It just means that this grammar is not LR1 in its current form. So if we had another reduction in the same state on the same look ahead, so same state and same look ahead, but you have another reduction, then this is a reduce error. Reduce error. So it means multiple possible reductions in the same state and on the same look ahead. Okay, so on an A, we are in S1 and we get an A. So we shift to S3. Shift and go to S3. If we get an B when we are in S1, nothing. Now, if we are in S2, S2, do we have reductions? No, we don't have reductions in S2. So if we are in S2 and we get a B, then we go to S4. If we get anything else, it's invalid. If we are in S3 now, S3 there are again no reductions. So in S3 we only have a valid transition on a B to S5. Okay? If we are in S3 we have a valid transition on a B to S5. Anything else is invalid for S3. Now let's look at S4. Do we have reductions? Okay. So do we have multiple reductions on the same look ahead? No. So we have multiple reductions on different overheads, which is good. Look ahead, sorry. So we have reductions on what? End of file and A. So end of file and A we reduce to 2. Reduce to if the look ahead is end of file or A. If we have a B, that's invalid. Okay. So this is S4. Now finally S5. Do we have reductions? Yeah, we have reductions on end of file and A are 1. And if we have a B, nothing. Now let's apply this to a string. Now this is a reduce. We talked about a reduce error. What's a shift reduce error? What's a shift reduce error? It means that both a shift and a reduce are possible. So for example, here R2 is possible on an end of file and an A. So if we had a transition on an A, because a transition on an A would mean a shift. So if we have a transition on an A and a reduce on an A, then this is a shift reduce error. Because both reducing and shifting, both are possible. So that's a shift reduce error. Okay, so let's trace it now on a string to understand what's going on. So let's use the following string, AB, AB. And our look ahead is here. So first we look at the stack. The stack will have, initially it will have S0. We push the initial state on the stack. Then all of our decisions will be driven by the action table. So the action table is going to tell us what to do next. So okay, we are in S0 and our look ahead is an A. The action table tells us to do what? Shift and go to state 2. So shift means moving this and going to state 2. So now we are in S0, we shifted an A, and we are in S2. Okay, because this is an S2. Or S2. That's what the table told us to do. What? Okay. Then we ask the table, we look up the table for S2 and B. So we tell it, okay, we are in S2 and we are seeing a B. What should we do? The table says go to S4. So now, going to S4 means shift one more, S0, A, S2, B, S4, and we have shifted. So now our look ahead We have already shifted the A and the B, so our look ahead now is an A. Now we consult the table. We are in S4 and our look ahead is an A. So it tells us if you are in S4 and your look ahead is an A, reduce by rule number 2. So this is what the table says. Reduce by rule number 2. So the reduction, we have to be careful now when we do the reduction. Why? Because we have to first pop. Oh, in fact, it's going to be smaller. So what do we pop here? How many states do we pop? How many entries? Sorry. 4. So we pop off all of this. Because this is the AB that we are replacing. So we replace AB with an X. But before we replace it, we do the go-to relative to the S0. The go-to relative to the S0. So we do go-to of S0 and go-to to S0 and what? X, because we are replacing AB with an X. So this is the X. So go to S0 and X, and this equals S1. So we push the S1, the X, and the S1. So this is probably the trickiest one. So you first pop, then you use the state after popping to look up where to go to in the go-to table. It tells you S0 and X go to S1. So now we are in S1. So what we have done so far is that we have reduced this AB into an X. So this is what we have done so far. We have reduced this to an X. Now we look up the table for what? What should we look at the table now? S1 and A. It says, okay, if you are S1 and A, then shift to S3. Now, see the importance of the look ahead. So if the look ahead had been an end of file, it would have said accept. But our look ahead is not end of file. Our look ahead is an A. So A, it means keep shifting. But if it had been an end of file, it would have said accept. So now the next is going to be, okay, shift and go to S3. So it's going to look like this. S0, X, S1, and A. And we are in S3. Okay, so now we look at the table. We are in S3. It says we are in S3. We shifted the A, so our look ahead changes now to B. Why? Because we shifted the A. So now we are saying, okay, we are in S3, and we are in S3, and we're seeing a B. What should we do? It says shift to state 5. So we shift to state 5. State 5, S5. So we do this. Now S0, X, S1, A, S3. What should we put? B and S5. Okay. So now we have a bigger stack. We have 6 plus 1 on the stack. Then we consult the table again. We say, okay, we are in S5. We are in S5, and we are seeing what? We are seeing end of file because we shifted this B, so we forgot to do this. So we shifted the B, so now we have an end of file. So it tells us, okay, if you are in S5 and you are seeing an end of file, then reduce by 1. Reduce by rule number 1 is going to replace X, AB with X. So replacing 3 symbols with 1 symbol. So when we are replacing 3 symbols, how many items in the stack do we pop off? 6. 2 times the number of items. So we pop off 6 items. So now we are here. And this is our base state. So now we look at go to of S0 and X. And this is going to be S1. So we will put the X, which is what we replace XAB with, and then we put an S1. So we are back in S1. Okay, so now we are in S1 and we are seeing end of file. So the table says accept, you are done. This is the valid string and you are done. So we just accept. So now S0 and goal and accept. Okay. So now the logic here is we're looking at this state transition. So we initially were in S0 because we saw an A, tracing this, because we saw an A, we went to this to S2. Then we saw a B, so we went to S4. And when we went to S4, we are ready for a reduction. We can reduce the AB to an X. Now, when we reduce the AB to an X, we're like replacing AB with an X. So we're replacing these two transitions with this transition relative to the base state, which is S0. So that's why when we pop off, we look at the base state after popping off. So after we pop these off, we looked at S0 because we're saying, OK, we're replacing AB with an X. So instead of making these two transitions to an S4, now we are making one transition with an X relative to the base state, which is S0. So this is what the substitution or the replacement or the reduction means. Instead of these two transitions, we are making a transition to S1, and that's why we are here in S1. So now we are here. Then we are reading an A, so the A takes us to S3. Then the B takes us to S5. But then in S5, when we are in S5, there is a rule that tells us if you are in S5 and you are seeing a look ahead, then you reduce by number 1. And reducing by number 1 is going to replace XAB. It's going to replace 3 transitions, all these 3 transitions, with what? With an X. So instead of making this XAB, we are popping this off and replacing this with a single X. This is exactly what a reduction means. It replaces potentially multiple symbols with a single symbol. So a reduction will always replace a number of symbols with only one symbol, which is the left-hand side of the production. And on the left-hand side of the production, we only have one symbol because this is a context-free language. This is exactly the definition of a context-free language. Okay, so we replace this with an X. Now, with the X, we are back in S1. So our state is S1. But in S1, if you are in S1 and you are seeing end of file, then the action table tells you to accept. Okay? So does it make more sense now? Okay. Yeah, so this is a kind of topic that is, that recording the lectures can help with. So you can watch the lecture again if you are in doubt of anything. So I hope that recording will help with this. Okay, any questions? Good. So we have 5 minutes. We'll get started on one of the. I will get you started on one of the homework questions. This is enough. We won't need more than this. Okay. So one of the homework questions is a simpler version of the classic expression grammar. So we have goal goes to expression, and expression goes to term plus expression, and expression also goes to term, and term goes to term to factor times term. And term goes to factor. And factor goes to identifier. This is a homework problem, and I will just get you started on this. So we only have 5 minutes. We will not get the chance to do the whole thing, but we will do the first 1 or 2 steps in the solution. So this is 0, 1, 2, 3, 4, 5. Okay, so now this looks simpler than the classic expression grammar that we are used to. Why do you think we are using a simpler form of it here?
Because there'd be too many steps.
Yeah, if we do the full classic expression grammar that we had in previous lectures, there will be too many steps and too many states. In fact, this is already going to be lots of states. I'm not going to tell you how many. So I will leave it for you to figure it out. So now what's the start state? So let's just do the start state. The start state here, we start with goal goes to expression and end of file. So this is the easiest part. Now, what does this imply? All the definitions of an expression. So all the definitions of expression, all the productions that define expression. So we have expression, term plus expression, and expression, term. Where should we put the placeholder? In the beginning. We're in the initial state. So this is here. Okay. And what's the look ahead? End of file. Okay. Now, what does this imply? So now we have term, right? So term is going to imply the definitions of term. So this is level 0, level 1. So now level 2 is going to be the definitions of term. So term it has 2 definitions. Term, factor times term, and term goes to factor. There are 2 definitions, and the placeholder is here. Now the question is, what's the look ahead for term?
Plus.
Is that it?
And end of file.
And end of file. Because if we're substituting term for this, the look ahead is this. This will come after term. So for this definition, the look ahead is going to be plus. But with this definition, term will be followed by end of file. So there are 2 possible followers for term, plus and end of file. Plus and end of file, plus and end of file. Okay? So we have 2 possible followers. Now this is level 2. Now what's level 3? Factor. Yeah. So now factor, we put all the definitions of factor, and luckily we only have identifier. So this is level 3. Now, what are the look aheads for factors?